Good afternoon, everyone. How are you all? Fine. Okay. So today come to a new topic: motion of a car on a banked road. Okay. So when you are going in a car, no. Okay. Suppose you want to take one circular turn somewhere. Okay. For car is a four-wheeler, right? So actually, car cannot rotate its body itself by itself. So that's why road will be banked. Okay, road, some inclination will be there for road. That is called basically banked road. We'll try to understand what is that. Okay. So by that way, this car can take a circular turn. Okay. So we'll try to understand that. So please everyone write heading. New heading, right? Right. Motion of a car. Motion of a car on banked road. So already we studied about level road. Now the banked road, you try to understand what I am telling here. Now suppose a circular turn is there now here. Suppose a circular turn is there here. Circular turn. Okay. Suppose a cycle is going. A cycle, normal cycle is going. Yes or no? Now what actually you can see, circular, basically you can see in the motor race. Okay. MotoGP, right? Race is there when race is happening, no? Motor vehicle race. That time what you can see? Well, motorcycle will be going. But when circular turn is there now, this motorcycle they will be bending like this. Have you seen or not? And for that one in their knee now, some wheels will be there. While they are taking circular turn now, their wheels, that rider wheels, that knee will be touching the ground. That's why it will be given. So why they bend like this? Now because suppose this is a circular turn, right? In that circular turn, when this person is going, it is bending like this. Because in the circular turn, this is the center here. Here it is center. And I already told if any particle moves circular path, then definitely there should be a centripetal force towards center. Yes or no? And force is required to move in centripetal. Now when this car is going, or sorry, that a cycle is going, or a car is, that what is that? Motorcycle is going, or a cycle is going, or bike is going. So when circular turn is coming now, if they rotate themselves, if they rotate like this themselves, what will happen? A component of the normal reaction will be like this. One component of the normal will come towards the center, which will provide necessary centripetal force to remain in the circular path. Otherwise, what is suppose they will not turn like this, they will go straight like this one, somewhere they will hit to the boundaries and all. Are you getting or not? So that is the reason they are bending themselves. So two-wheeler very easy to bend themselves. Yes or no? Two-wheeler easily they will bend. But what about car and all? They cannot bend themselves, right? Car will do bend like this, will go like this. It's not Hollywood movie, right? Yes or no? Normal we are riding when we cannot bend car themselves, or car cannot move. It's a component. Car when car is moving now, it's a normal reaction always vertically upward for that floor, wherever floor is standing. So the thing is what? Now these two-wheelers they will bend themselves and they can make a circular turn perfectly. But for car and all, what we will do? Now we will design. We will use some engineering idea and we will design, basic concept of physics we will use, and we will design on the path. What path? Now we will design like this. We will make little angle. From the horizontal, we will make certain angle here, theta. Okay. Now what will happen here? Now suppose this is your car. This is your car. Now listen. This car is going now. Now what is happening here? This see, if we know we did like this, then what happened here? The normal reaction became like this one. This is a normal reaction N. And in this direction friction will be there. Let me take care of this is the friction. And here you will have mg. Here you will have mg. Let me write here mg. This is your mg. Mg is like this one you take. Mg is always vertically down. So mg will be like this. This is your mg. Okay. Now what happened you see? Now when we tilted this, we making certain angle from the horizontal, then this normal component is not, before normal component was like this only. If it is not theta is 0 now, normal component will be vertically up. But now see normal component it tilted some angle, right? Yes or no? From the vertical it tilted some angle theta. Whatever this theta, same theta will come there. That means what happened now? Now to the circular this car, if you want to take a circular turn like this, then what will happen here in this direction? Now I'll have so many component of the normal reaction and friction, which will provide necessary centripetal force to move in this circular path. Are getting or not? So now what is happening? You can see car cannot bend themselves. So what we'll do? Now we'll make car to bend by the road. We'll bend, we'll bang the road, we'll make. Okay. Are getting or not? Now here, free body diagram I'll do here. What is the free body diagram? Now free body diagram of car if I'll do, now what I'll get here? Now like this I have one inclined plane. You can understand already inclined plane I told you. Now this is the angle theta. Now here you have a car, right? Now listen. Here you have a car. Now what happened here? Now here you take like this one, some axis. So let's take here in this direction let's take one axis. In this direction you take this horizontal now, or a vertical horizontal you take, no reach. Vertical horizontal you take like this. X axis, Y axis take. So this is suppose center origin you take. Now you consider like this Y X axis. You consider like this Y axis. You consider this one to solve this question. Okay. Actually what we need to find here? Now when car is moving now, it is moving with certain velocity. So what will be the safe velocity so that this car can move perfectly? That one we want to find. For that one I am doing one Y axis and X axis. Now here what I did, here this is my friction, this is the frictional force, always it will be acting like this only, frictional force, and this is the normal reaction, like this, already tilted now, this is the normal reaction here, and mg is vertically downward, I wrote. Now what I want to do, now I want to see if this angle is theta, now this angle also theta. Okay, what is that angle? That is with x axis, friction is making angle theta. 1 minute. If you geometrically check, not that angle theta exactly, this angle you take. This angle will be, if this angle theta, correct. 1 minute. This angle take theta. This is theta, and this also will become theta. One n cos theta and sin theta component will come here. Okay. See here, this is right angle triangle is there. You can check carefully. Here, this and this are parallel basically. You check correctly. Now this is 90 degree here. If this angle theta, that angle also I can take theta. Are you able to understand or not? Theta angles check. Inclined plane angle is theta. And if geometry will see, friction is making certain angle. Theta with the x-axis. Friction is making theta angle with what? X-axis. From the geometry you can prove this. No reach. Geometry you can prove this. Now next listen here. Now if f is like this, theta is like this one. Now what is this component? This component is your f cos theta. And this component will be what here? Here another component will come f sin theta. And listen, n will have two component. Vertically upward direction one component will be there. Okay, that component is basically what? This component, vertically upward direction. It will be n, tell, cos theta or sin theta? Theta connected axis, cos theta. Now in this direction one component will be there. What is that? F cos theta already there. Then it is n sin theta. Now you check properly what we did. Already only three forces are there, but their component we did. So if this angle is theta, this angle will be theta, then f cos theta will be this direction, and n sin theta will be in this direction, which will provide necessary centripetal force. I told you this particle is moving in this circular path like this. Okay, so this total component will provide you necessary centripetal force to move in a circular path. Now what we'll do here? Now we'll try to check equation of motion. in x-axis, in y-axis. This x-axis, y-axis. In y-axis there will be no motion. So n cos theta will be equal to mg plus f sin theta. From there you can try to find n. After that we will try to equate that f cos theta plus n sin theta equal to mv square by r. Okay, that one we will try to see. F cos theta plus n sin theta will try to substitute mv square by r. So first to do the free body diagram. This theta now from geometry you can find. You will take one dot like this, and here you have this axis, and you are telling this angle is theta. So this is 90. So definitely this will be 90 minus theta. If this is 90 minus theta, this is already 90 there. Now this angle will be theta. So this is what your friction. This direction you have friction, and this direction is x-axis. Now this angle coming theta. This is theta. Now normal reaction is this way. Now this angle total is 90. If this is theta, then this will be 90 minus theta, because f and n are perpendicular to each other. Then definitely this will be theta. So from the geometry I am getting this one. You directly remember friction is making theta angle with x-axis. Normal reaction is making theta angle with the y-axis. That is what you remember directly. From geometry it will come. Okay. Then after component we are taking f, two component it will have. Okay, you know any vector can be resolved into two components, perpendicular axis. On the perpendicular axis it can be resolved. So one is f sin theta, one is f cos theta. Theta connected axis always the cos theta component. Here theta connected axis similarly n is having two components. Theta connected axis, so it is going to vertical y, that is n cos theta, here n sin theta. So this is all the scenario you are understanding about a motion of car. Okay, on a banked road. And if you will understand what is theta here, now theta you can give. Theta is basically angle of inclination. If these two dot white line dot vertical line if I will take now, then this friction is like intersect. Then after, if this angle is theta, then definitely this angle theta. Like that also you can tell. Okay. So how you are understanding, you understand. But remember we have done one x-axis, y-axis, and we are components we have taken. Basically three forces are there here. One is normal reaction, friction, and gravity. Okay, we are doing like that. Component we have taken, we have to understand now. Now this component, this will provide necessary centripetal force to move in a circular path. Okay, but in vertical there will be no motion, so this and this you can equate directly. So let me go for next page. Did you complete? So three component force, do y-axis, x-axis, then after resolving to. Friction is resolved into two component, normal reaction resolved into two component, that's it. mg you kept as it is. Okay. So here one friction component is there here, one friction component which is f sin theta. Now next listen, all of you listen carefully. In vertical axis you will check, in y-axis, understand all of you, in vertical axis, y-axis. In y-axis there is no motion. Okay, so upward force equal to downward force, that one we can consider. So I can consider here n cos theta equal to mg plus f sin theta. Now next listen, I can write here n cos theta minus f sin theta equal to mg. This one I can take this side. Now n cos theta minus, you know friction always nothing but what friction? Now friction is mu naught or mu s into normal reaction. This one already you know, you have idea, mu s. Okay, f equal to mu s into n, coefficient of friction into n. Now sin theta is equal to mg. That means you can understand here this is basically rough surface. The surface is rough. Here coefficient of friction you can take mu s. Rough surface, coefficient of friction what I can take? Mu s. Okay, static friction I took. So that means here mu s is what? Now you are substituting Fs equal to nothing but, or F equal to friction, which is mu s times n. Now what I'll do here? Here I can take n common. It will be cos theta minus mu s sin theta equal to mg. Now here I can write n. What is n? That is mg divided by cos theta minus mu s sin theta. Mu s sin theta. Yes. Now this is the normal reaction. This is the normal reaction. Okay. Cos theta minus mu s sin theta. Now in y-axis if we will take, why I wrote n cos theta equal to mg, because in y-axis there is no motion. So if no motion is there, then upward force equal to downward force. This is what we did. Total upward force equal to total downward force. Now you got n equal to mg by cos theta minus mu s sin theta. Note it down. Here what we'll do, now in x-axis we'll try to see. In x-axis, if you'll see here x-axis, what is happening here? Now in x-axis you have f cos theta plus n sin theta, this component total. One is due to friction, one force component, due to normal reaction, one force component. Hello boys. Now these two are providing necessary centripetal force to move in a circular path. I told here they are moving in a circular path of radius r. Car is moving, taking turn. So now what we'll do, in x-axis if we'll try to see here, now f cos theta plus n sin theta provides necessary centripetal force to move in the circular path of radius r. You give small r, capital R, anything is okay. You give small r, no worries. But understand r is the radius of circular path. Now here f is nothing but, already you know. What is f? What is f formula? F equal to mu times n. So now it is mu s times n cos theta plus n sin theta equal to mv square by r. Now n take common, it is mu s cos theta plus n sin theta. So n taken already common now. If n taken common, then only sin theta will be there. So sin theta then equal to what? mv square by r. Already n value you got something. What you got n value? Now mg divided by cos theta minus mu s sin theta. Now already you have here mu s cos theta plus sin theta. Yes or no? mv square by r. Now what we'll do here? We'll try to check this one here. Commonly we'll write here. Let's write here like mg mu s cos theta plus sin theta. Together we'll write. Here it is cos theta minus mu s sin theta. Now you can check here m and m get cancelled. M and m will get cancelled. M and m can get cancelled here. So whatever remaining here v square. So whatever remaining here, it is v square. I write r into g. Okay, m is getting cancelled. This r you take left hand side. This r you take left hand side. So mu s cos theta plus sin theta divided by cos theta minus mu s sin theta. This is what you are getting now. Okay. Rg is there, Rg multiplication equal to v square, Now, if v square I want to write, v square equal to Rg mu s cos theta plus sin theta. Same thing again and again I am writing. Okay, just to make a v square in the left hand side. Now next listen here. Now here, if you want to find v square root, I can get this value. But here what I want to do, here I don't want to keep as a sin theta and cos theta. I want to make it a tan theta. How I'll make it a tan theta, you say? If I'll divide cos theta in numerator and denominator, then cos theta will get cancelled, sin theta by cos theta will become tan theta. So let's do that one. Rg equal to, sorry, V square equal to Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So how I did this one? I'll write here, dividing what? Dividing cos theta in both numerator and denominator. Write down here. Dividing by cos theta. So now this is what you are getting, V square. Now if you want to write V, that will be root under Rg mu s plus tan theta by 1 minus mu s tan theta. This is what you are getting. So this is the velocity with which that car can move in that circular turn. So this is the safe velocity. Okay, and this is the maximum velocity. The maximum velocity. So you can write this one as, you can give it as V max. So it is your maximum velocity. Maximum velocity for safe turn. Maximum velocity for safe. Okay, safely you can go in that turn with a maximum velocity this much. Less than this also you can move, but more than this now you will fall down, out of the track you will become. So this is what you are getting. X-axis, Y-axis you understood, and you got this big expression. Sometimes directly this is one asking in entrance exam, directly, formula. Okay, or they will give a theta value, mu s value, r value, g value, you have to find maximum velocity. Okay, or any given, not given now, for quantities, 3 quantities given, whatever, you check and do. So remember direct formula, V max equal to root under Rg mu s plus tan theta by 1 minus mu s tan theta. Understood everyone? Okay. Now here one small thing, try to get the point. If there is no friction, what will happen? Mu will be 0. Then V max will be what? Root under Rg tan theta. Okay. So when there is no friction, only normal reaction will provide necessary force to move in a circular path. Okay. So that also you can understand. Because with this now, two things can happen. Friction we can keep, we cannot keep also. Without friction also you can keep. If friction you are omitting, then mu s you put to 0. That's it. So let me write some condition here. So where R is what? R is radius of circular path. Radius of circular path, and mu s is coefficient of static friction. Coefficient of static friction. And theta already you know. Star mark right here for, or condition, right? Condition for safe turning or no sliding or no skidding. Okay, that conditions if you can take. No sliding means friction. Okay, safe turning you write. Condition for safe turning. First you write this one. Your maximum velocity should be equal or less than root under Rg mu s plus tan theta divided by 1 minus mu s tan theta. Yes or no? This is there, right? Okay. So less than equal you write. Condition for safe turning or no skidding or no sliding, write that. And another point, write if mu s equal to 0, mu s equal to 0 happening, then what will happen to this expression? Now V max will become root under Rg tan theta. Root under Rg tan theta. Okay. So maximum velocity will be Rg tan theta. Less than that also car can move. Okay. If there is no friction, mu 0 means bracket to right. No friction. There is no friction. So difficult formula maybe looks big, but you try to remember. So Vs equal to root under, okay, root under what? Rg bracket mu s plus tan theta by 1 minus mu s tan theta. That's it. Up will be mu s plus tan theta. Down will be 1 minus mu s tan theta. So if mu s 0 na, only tan theta will be remaining here. 1 minus 0 is 1. That's it. Okay. So that is what you understood today. So a car cannot turn itself or cannot bend itself. So that's why you have to bend the road. Yes or no? With certain angle theta. Certain angle theta. That's all about this one. You remember. Okay. Did you understand? Okay. If you understand, like and subscribe Vidyalayakshmi NEET Academy YouTube channel. All the very best. Thank you.